Alright, so the first three are pretty straightforward. Just using the identities. For number 6, you do have to write cotangent squared x in square root so that both sides could equal. And then you simplify it, and then you get the absolute value of cotangent of x. Again, 9 is pretty straightforward. 3 is the same. Number 12, I went over this in class, and just point to this. These are just reciprocals. And then to get these two, I could use identities, but you could also use triangle. So I use this ratio right here to label this side and this side. And so I use Pythagorean theorem to get the hypotenuse. And so that gave me sine, which I simplified to that, and then cosecant. Okay. Number 15, you have 1 over tangent squared x plus 1. So you replace this with this, and then 1 over secant is cosine, so you get cosine squared x. Number 18, I switched it over to sines and cosines, so secant is 1 over cosine. Notice that the negative is no longer there because secant of negative theta is positive secant of theta. And even if it was negative, the square here would get rid of the negative. So you end up with this ratio right here, which is the same thing as 1 over cosine squared x times the reciprocal of this, and that's sine squared theta over 1. So I'm sorry, I said x. It should be theta. And so sine squared theta over cosine squared theta is tangent squared theta. Number 21, you have tangent of pi over 2 minus x times secant of x. So I use the cofunction of this one, which is cotangent, and then this I left the same. Then I changed them to sines cosines. So cotangent is cosine over sine, secant is 1 over cosine. These two cancel, and you're left with 1 over sine, which is cosecant. For number 24, I factored the numerator. It's difference of two squares right here. Then I factored out the GCF from the denominator, which is sine alpha, and you're left with this. So now notice that this factor and this factor cancel out, and so you're left with sine alpha plus cosine alpha over sine alpha. So I'm just separating it, the fraction, same denominator, so that's this over sine alpha, alpha, and so that gives me 1 plus cotangent alpha, and that's all you can do for this one. Alright, so number 27, I'm going to make the left look like the right side. So first thing I'm going to do is use Pythagorean identity to replace cotangent squared x plus 1 with secant squared x. And I'm going to break up one of the secants to 1 over cosine, and the other one I'm going to leave as a secant. So here's one secant, here's the other one. Okay, so why did I do that? Because now I can cancel these, and I am done. Alright, so I'm going to work on the right side to make it look like the left. So I'll put on the right hand side. I'm going to replace cosine squared x with 1 minus sine squared x. Then distribute. So that gives me cotangent squared x minus, and I'll write cotangent is cosine over sine squared, of course, times sine squared. Okay, I did the applied the distributive property. So the signs are gone, and I'm left with the left side. Cotangent squared x minus cosine squared x. Alright, so I'm going to work on the right hand side again to make it look like the left. So I'm going to factor out a cosine squared x first. So get 1 minus 2 cosine squared x plus cosine to the 4th x. And I noticed that this is a trinomial that I can factor. It's actually a quadratic. So this is going to be cosine squared x. Bring it down. This is 1 minus cosine squared x minus cosine squared x. I'm going to replace each 1 minus cosine squared x with sine squared x. Sine squared x, there's 2 of them. You multiply together and you get cosine squared x times sine to the 4th x. And then just switch the order so that it looks like the left side exactly. So, okay, so here are the steps. So number 1 on page 461 is the law of sines, because we were given 2 angles and one of the sides. So we do have opposites, because we find angle C. Given these 2 angles, we could find angle C, which now gives us opposites. I have the side C and angle C. So here's the law of sines right here. And this is how you would set up for A. You cross multiply, you use this ratio and this ratio. You multiply this times this and divide by this to get your A value. For B, you multiply this times that and then equals to this times this. So when you solve for B, this is what it looks like, and there's the answer. Okay, so these are the 3 values for the missing measurements. Alright, so for number 2, it's pretty much the law of cosines, because you are given 3 side measurements, no angles. So you look for the biggest angle first. So you take the biggest side, and that's the one that you, that's the angle that you look for. So if it's side C that's the longest, then you look for angle C. So here's the setup. Again, it's pretty much all calculator work. You do inverse cosine of this ratio, and you get this. For cosine B, same thing. Notice the setup here. Put this into the calculator, inverse cosine, and this is the angle. For angle A, I just went ahead and added these together and subtracted from 180 to get your 22.33. So for number 3, another law of cosines, because we have no opposites. We have angle A, but there is no side A here given, so I had to use the law of cosine. So here, since I have angle A, I solve for side A. And here's the setup. Okay, and then this is just all the work. Put into the calculator, and you get A is approximately 7.12. So next, we solve for one of the other angles. So here's the law of sines, and the reason I switched over to the law of sines is because I already have that side. So now I have opposites right here, and so I need to find angle B and angle C, and I went ahead and found angle B first. Notice here I wrote use unrounded. So if you use 7.12, you'll end up like with 40.25 or something. So this will be wrong. So go back to this number over here and use it in place of this. Okay? And when you put that into the calculator, you get 40.11. For angle C, you just add this angle and this angle, subtract from 180, and that'll give you your angle C. Alright, so number 4, sorry, not 5, number 4, it's another law of sines problem, because we do have opposites right here, the angle and its opposite side. So I went ahead and found angle A first, since you were given 2 angles. So add them together, subtract from 180, so you get 88 degrees. Then you set up the law of sines. To find A, you cross multiply, and you end up with this ratio right here. Put it into the calculator, and you get this. For side C, cross multiply these two, set them equal to each other, solve for C, and so this gives you the ratio here. Plug it in, and this is what you get. Alright, so for number 5, this was a law of sines an ambiguous case, because they gave you side-side angle, and here's the drawing of it right here. First I calculate H, and so you can do H by getting this expression right here, and you got 11.83. So because this measurement is shorter than this one, and this one is shorter than this one, then you know that there are 2 triangles, or 2 solutions. Okay? And so now you have, the first thing you find is B1. So here's how you set it up, because that's what's given to you right here. So those are the measurements that I used. I found B1, and then I found B2 by doing the supplement right here. And then I found C1 by adding B1 plus the given angle. So here's the work right here. I found C2 by taking this angle right here and adding it to the 25 degrees and subtracting it from 180. So here's the work right here, and the answer is right there. And then I went ahead and found the sides, C1 and C2. So here's the law of sines, and here's the law of sines. You cross multiply, and then you divide by sine 25 to get C1, and this is what you get. And then for C2, you cross multiply. So you multiply these two, and you divide by this to get C2 by itself. And here's the answer.
Hi. Hi, my name is Nathan. Hi, my name is Andrew.
Alright, thank you guys. Alright, for number 6, you have angle B 130, and this is an obtuse angle. And because of that, since this side is shorter than this side, you automatically have no triangle. Alright, for number 7, you have to find the length of x, the length of the pond. And so you have to set up the law of cosines because you have side angle side, no opposites. So there you see the work, and it's pretty much calculator. I just put it in the calculator just like I saw it, and this is what you get for your answer. Don't forget, take the square root of x squared to get the answer. For number 8, it's an area problem. They want you to find the area of the parcel given those dimensions. So first you have to find S, which is a semi-perimeter. So you take all 3 measurements, add them, divide by 2, you get 120, and then use Heron's formula. So it's S times S minus side 1 times S minus side 2 times S minus side 3. Multiply 4 numbers together and take the square root, and you end up with this.